The voltage-controlled switch matrix is a great addition to any small system. With some clever patching, it can be used as a dynamic waveshaper to add new shapes to any basic VCO. The voltage-controlled switch matrix can either switch a single output between two inputs or a single input between two outputs. We have 8 volts normaled to in A on channel 1, and with nothing patched to in B, we can use the gate input to switch back and forth between 8 volts and 0 volts. By applying a triangle wave to the gate input, we'll find a square wave at the output. I'm going to set this up quickly by patching our triangle wave to our oscilloscope just so we can view it for reference, and that's going to be molted to the gate input. The output will be patched to input 2 on our oscilloscope, and we can listen to it by patching the molt to the output of our OCOS. This seems maybe pointless because chances are your VCO already has a square wave output. But if we take that triangle wave and we mix it with the DC offset before we apply it to the gate input, we'll have control over the pulse width of that square wave. Listen to it get more narrow and wider as I adjust this knob right here. By replacing the DC offset with something like an LFO, we'll have voltage control over the pulse width. And if we take our output from channel 2 instead of channel 1, we'll hear a square wave an octave lower because of the built-in clock divider. We can even create saw waves by using another channel of the voltage-controlled switch matrix. We're going to molt the triangle wave again, to the input of channel 4. And we're going to take each output and patch it into a mixer. One of the inputs on the mixer needs to be inverted, so make sure you have an attenuverter at your disposal. And lastly, we're going to take the square wave from our oscillator and apply it to the gate input of our switch. When we take the output of the mixer, we'll see a saw wave on our oscilloscope. And we can listen to it by applying it to our output. Notice that it's an octave higher than our initial triangle wave, and if we take the inverted channel on our mixer and make it non-inverting, it'll go back to a triangle wave. If we used a 4-quadrant multiplier, we could have voltage control over this new shape. Let's use the bottom section of our mixer module here to mix all of these new waveforms together. So we have our triangle wave, our pulse width modulation, and our saw wave coming out of the second output of our mixer. And we'll apply it to the output on our zero coast. Listen to how it compares to the initial triangle wave. Maybe we want This is with the initial pulse width, modulated square wave, and back to the one an octave below. This is just an introduction to the many waveforms that you can create with a voltage-controlled switch. Many more complex waveforms can be created by varying the source material and the switching frequency. Feel free to share your own patch ideas in the comments section below.